This video lecture is a continuation of the walkthrough for hurricane exercise part 3. This is the last part, so we have previously gone through working with death and damage data for tropical cyclones in the North Atlantic. We took data from 1900 to 2019 and we computed real dollars from the nominal dollars of damages, so we could look at damages over time. We look at the summary statistics, we computed histograms, we looked at trends, and we looked most recently at relationships in two ways, looking at the correlation of death and damages with a scatter plot and a trend line. And then we also looked at it with a correlation value, which we verified by computing a p-value, so we could decide whether or not we can trust that value. So the last bit we're going to do here is we're going to look at data in a slightly different way. So on your worksheet, in the bottom of the sheets listed, the very last one should be the one that says TS 1851 to 2018. And if you click on that one, you'll see this data set here. And what we're looking at is an even longer list of events, hurricanes, or hurricanes in this case, going back to 1856. So we've got quite a bit of data here going up to 2019. So we see here the first column, those are the years of data we have. And then this one is a list of deaths, basically, but it's focused particularly on deadlier events that had 25 or more deaths in them. And so what we have is the month in which the most deadly one occurred for that given year, and then with the abbreviation of the state in which it occurred, in this case Louisiana, and then we have the 4, that number there means the category of it on the Saffir-Simpson scale. So we had a major hurricane hit Louisiana in 1856 in August. You have other columns, again, in cases where you have several events happening, it lists the highest one in this, again, the category of hurricane. The central pressure column, when we look at hurricanes, hurricanes are ranked by their wind speeds. That's how we come up with the scale or the category of the hurricane. And winds are a function of air pressure. So at the center of a hurricane, usually a very low air pressure. They're basically like giant vacuums sucking in air. And the lower the air pressure at the center of the hurricane, the faster and stronger the wind. So that's usually a good indicator of how powerful the storm is basically the lower the air pressure. And if you pay attention to the weather reports, when they talk about hurricanes, they'll frequently remark on that, particularly for more powerful ones. You see maximum wind speeds, in some cases some information about where it hit, and then lastly in the last column the number of deaths that were associated with those events, although they're not really separated out. So you can see in some cases there were a number of hurricanes that hit different states, Mississippi, Alabama, Florida, and then different parts of Florida, Louisiana, and then those are kind of all combined into that death number. So it's a little ambiguous, but in any case, what we're looking at here is a lot of interesting data that goes back really far. It's really long historical record. And what we're interested in here is we're interested in looking, again, going back to the concept of expected deaths. If we were looking at this historical data on deaths from hurricanes, and we were trying to kind of put together an assessment of the likelihood of death in any given year from hurricanes, how could we use this data? So what we'll do is we're going to do this for Texas. Texas is on the Gulf Coast, and it's very subject to hurricanes, and it had some pretty big ones. Think of Hurricane Harvey not too long ago. And so in order to do that, we need to pull out data from Texas, from this data set, in order to isolate just what's going on in Texas. So I want to show you some tools that allow you to extract data when it's kind of messy like this. It's mixed in with text, which can be useful. So again, we're going to compute the expected annual fatalities for Texas. That's the goal here. So we're going to need several numbers in order to do this, because this is just like we did at the very beginning of the Hurricane Part 3 exercise. So we want to know the fatalities in Texas. All right, that's what we're after. Now, to figure that out, we have to somehow parse out Texas's information from this table, right? So you can see that Texas is scattered throughout, but oftentimes it's mixed in with other text in there, right? So we see here Texas, Louisiana, right? And it's kind of not always in the same place. So what we're going to do is we're going to use another logical function that can separate things out depending on the condition that we give it. So this time we're going to use a SUMIF function. So SUMIF begins like any other formula, SUMIF. And basically it's going to say, okay, look at a range of data and tell me if when you find this condition being met, then you can add that up. So we're going to say, look through this column of data in the C column where we have all the states and numbers in there. All right, look through that and then put a comma here in the formula, and we're going to set up the criteria. So we say, okay, I want you to identify whenever you encounter Texas. And so the way that we set that up is we'll again put an equal sign to say when we find this particular condition. And we want it to find TX, right, which is how Texas is represented in the data set. But notice that Texas is often near other text, so you see other letters near it. So what's hard is that we need to be able to, for Texas to be kind of pulled out of that data. So one way we can do that is to add what are called wildcards. And this is an asterisk or the little star symbol. Then we put TX and then again with the asterisk and then close off the quotes there. So the little asterisks in front of the T and after the X, what they mean is it doesn't matter what comes before or after, what becomes before the T or what comes after the X. As long as you find TX next to each other, then please count that. That's what that means. And so those wildcards are really useful. It's kind of a programming legacy, a syntax, a way of allowing you to kind of sift through complex data. So that first part says, look through the C column, find all the instances where you find TX together, regardless of what's surrounding around it. And then when you find that, we want you to count up whatever is in the H column, which is the deaths. So in those rows where you find Texas, count up the deaths, right? So we put in this range here in the H column. So I'll just highlight it. Okay, and you can see now on my formula, that's the last part of it. So I'll just put the closing parentheses and hit enter. So we can see that there were 9,713 deaths in years in which Texas had hurricanes, right? Now, keeping in mind, again, that we don't really know, like, for example, here, how many of these deaths were in Texas versus Louisiana. But nevertheless, this is as close as we can get for the moment. Okay, we're again looking for expected annual fatalities, so we need some other data here. We need to know how many years of data we have, right? So assuming this is a complete record, instead of counting up the number of years, if you notice there are gaps between years, but let's assume that between, let's say, 1856 and 1860, there were no significant hurricanes, right? So we still want to count the years in between. So the simplest way would be just to subtract 2019 from 1856, and that'll tell us, if we set up like a formula, put the equal sign, there we go, that there are 163 years of data that we're working with here. So that's pretty simple. Now we want to know the average annual fatalities. Okay, and so this is simple enough. So this is just an average, right? The number of fatalities and divide it by the number of years. Okay, that's it. So we can see that on average, if we just took those two numbers, we get 60 fatalities per year, right? So there's our average. Next, we need to know the return period. All right, so this is a little different. The return period, as you recall, is the number of years on average between events. So for this one, we need to know what it is for Texas, right? And this is something we have to look up. This is climatological information. So in the exercise, there's actually a link to that. If you go to one of the last pages, there it is. So this is something that NOAA maintains. So if you go to that link, you'll come to this tropical cyclone climatology page. And this is a really interesting thing to look through, just about kind of giving you both the history of hurricanes, but also to understand basically how common they are in different parts of the world. And what we're looking for is a particular map that shows us the return periods, right, or the recurrence intervals. And so we're looking for this one right here. So if we look at this map, we click on it and enlarge it, right, we can see the recurrence interval, return periods, all along the Atlantic coast, around Florida, and all through the Gulf. And so we're looking right here at Texas. So Galveston, or I should say, let's just pick a number here. So you see there's quite a range, right? If you're closer to the Louisiana border of Texas, it's lower, meaning they're more common there. And if you're in the southern edge with Mexico, it's a little less common. So we're going to go somewhere in the middle of Texas. So we're going to go with that 19 right there because that kind of sticks out to me. So we'll take that 19 as our return period. And so we'll just put that number in there. So we'll say 19. And then we need to know what the annual exceedance probability is for that. Okay, and that's pretty simple because that's basically just 1 divided by the return period. Okay, so we can see there's a 5% annual probability of this hurricane happening in a given year. And the last thing we want, which is what we're after, is this expected annual fatalities. Okay, so this one is, if you might recall before, is very simple too. Essentially, we're taking the average annual fatalities and multiplying it by the exceedance probability, which is the probability that you're going to have a hurricane to begin with, given the historical data. And that number right there is what you should expect annually of deaths. So notice in this case that this expected annual fatalities is very different from the average annual fatalities, right? And the reason is because it takes into account the actual probability of an event, which reduces the average in a sense. Okay, so we can see that for Texas, given this data that we have, and with a caveat that, again, some of these deaths are probably mixed up with other deaths, that the average annual fatalities that one would expect in Texas is about 3.1 per year. So the question now is, what is it for Massachusetts? So I want you to do the same thing, but to calculate it for Massachusetts. So in this case, we're going to be using the data that we have here. So when you look at the return period for Massachusetts, we're going to use the greater Boston area. So we're going to use that 30 as the return period. So you've already seen how the process works, so now I leave that last part up to you.